Now we're going to read about the application of the separation of variables in our real life for the mechanical engineer. Now we have a radioactive decay and carbon dating. As discussed in section, radioactive substance decomposes at a rate of proportional to its mass. This rate is called decay rate. Now if MT represent the mass of the substance at any time, then the decay rate is dm divided to dt is proportional to mt. Let us recall that the half-life of the substance is the amount of time for it to decay to 1/2 of its initial mass. We have an example. A radioactive isotope has an initial mass of 200 mg, which 2 years later turns to 50 mg. Find the expression for the amount of the isotope remaining at any time. What is its half-life? Solution. Let's assume m be the mass of its isotope remaining, and after t years, and let's use k to be the constant of the proportionality, and then the rate of the decomposition is moduled by dm divided to dt and equal to minus km, whereas minus sign indicate that the mass is decreasing. So this is important. It is a separate equation, separating the variables, integrating and adding a constant in the form we get ln m plus ln c equal to minus kt. By simplifying the equation, we get ln mc equal minus kt, or mc equal exponential minus kt. And we find c, and recall that the mass equal to 200 when t is equal to 0. Now putting these values and mt in for, we get this equation. Or C1 is equal to 200 and m is equal to 200 exponential minus kt. The value of k may now be determined from the substituting t equal to and m equal to 150. Now 150 is equal to 200 exponential minus kt, or an exponential minus k is equal to 3 divided by 4, or minus 2k ln 3 divided by 4. This gives k is equal to half ln 4 divided by 3 equal to half, and 0.2877, and we get 0.1 4 3 8, and we get that closer to 0.14. The mass is isotope remaining after t years is then given by mt is equal to 200 exponential minus 1438 t. The half-life t is the time corresponding to the m 100 mg, thus 100 is equal to 200 exponential minus 0.14 th, or 1 divided by 2 is equal to exponential minus 0.14 th, or th is equal to minus 1 divided by 0.14, then 0.1 equal this how many years? 4.95. Now we're gonna read another example about the process of estimating the age of the artifact is called carbon dating. So the carbon dating is the process of estimating the age of the artifact. Now we have the example. Suppose that we have an artifact, say a piece of fossilized wood, and measurements show that the ratio of C14 to the carbon in the sample is 37% of the current ratio. Let us assume that the wood died at time 0. Then we compute the time t it will take for 1 gram of the ratio active carbon to decay this amount by the model dm divided by dt equal to km. This is a separated differential equation. We write it in the form 1 divided by m dm equal to k dt. We integrate it to obtain ln m is equal to kt plus c. Since mass is positive, then m then the absolute of m is equal to m and ln m equal to kt plus c. Then mt is equal to exponential kt plus c equal to ac exponential of kt, whereas a is equal to exponential c is positive constant. Let at some time designed it at the time 0 there are m grams present. This is called initial mass. Then mo equal to a equal to m, so mt is equal to m exponential kt. If at some later time we find that there are mt grams, then m capital T is equal mt equal the same at m exponential kt. Then ln mt divided by m is equal to kt. We use hence k is equal to 1 divided by t ln mt divided by m. This gives us k and determines the mass at any time. Mt is equal to m exponential t divided by t small divided by t capital ln mt divided by m. Let t equal lambda be the time at which half of the mass has radiated away, that is half-life. At this time half of the mass remain, so mt equal to m divided by 2 and mt divided by m equal to 1 divided by 2. Now the expression for the mass becomes mt equal to m exponential t divided by lambda then 1 divided by 2, or mt is equal to m exponential t divided by lambda then 2. Half-life of C4 is 5,600 years approximately, that is lambda. Now we divided ln2 to the years is equal to minus 0.000012378. That means approximately equal to all decimals places are not listed. Therefore, mt is equal to me minus 0.0012378t, or mt divided by m equal to 0.37 equal to exponential minus 0.0012370. By given the condition that mt is 37 during t is equal minus ln 0.37 divided by 0.0012378 equal to 8038 years to 8031 years approximately. Survivability with AIDS, we're going to use separation of variables in MEDS field. Equation that provides survival fraction. It is ST. It is a separable equation, and its solution is ST is equal to SI plus 1 minus SI exponential minus KT given the equation. dST divided by dt equals minus K ST minus SI. ds divided by ST minus SI equals to minus K dt. Integrating both sides, we get ln ST, the absolute of ln ST minus SI equal to minus KT plus ln C. Ln ST minus SI, the absolute of that is divided by C is equal minus KT, or ST minus SI divided by C equals to E minus KT. ST is equal to SI plus C exponential of KT. Let S0 equal 1, then C is equal 1 minus SI. Therefore, ST is equal to SI plus 1 minus SI exponential minus KT. We can rewrite the equation in the equivalent form. ST is equal to SI plus 1 minus SI exponential minus T divided by T capital, where an analogy to radioactivity nuclear decay, T is the time required for half of the mortal part of the cohort to die, that is the survival half-life. Now we have another example. Consider the initial value problem, ds t divided by dt equal minus k st minus si, as zeros equal 1, as the survivability with 8. Now we show that in general the half-life t for the motor part of the cohort to die is t equal to ln 2 divided by k. Show that the solution of the initial value problem can be written as st equal to si plus 1 minus si 2 minus t divided by t. Now the solution of the separable differential equation is st is equal to 1 minus si exponential minus kt plus si. Let st is equal to 1 divided by 2 s0. Now solving for the t, we obtain the half equal life t equal to ln 2 divided by k. Now for the b part, putting k equal to t divided by ln 2, and for 18 we obtain st equal to si plus 1 minus si exponential t divided by ln 2 minus t divided by ln 2 multiplied by t.